Dear viewers, welcome to another video in the series of control charts. In our previous videos, we have seen control charts for attribute data. Today, we are going to see another type of control chart for attribute data, but this is slightly a different chart. The name of the chart is rare event charts. So under rare event charts, we'll be seeing two charts. One is G chart, another one is T chart. In today's video, we will see what is G chart. Let's get into the video. As I was explaining, this chart is a rare event chart. What do we mean by a rare event chart? Let us say I am a maintenance supervisor in a factory. Do I get machine breakdown ticket raised every day? No, it does not happen every day. Machine breakdown is a rare event. It happens maybe once in 10 days, once in 15 days, sometimes even once in 30 days. It's not a frequently occurring event. So whenever there is a machine breakdown event happens, I go attend it, but for my monitoring purpose, I am trying to plot it in a control chart to see whether this particular event, a rare event, is within control or out of control. And generally, if you think about machine breakdown, so it is count of events, right? I am responsible for a factory, a scope of area, and in that scope of area, whenever there is a breakdown, a ticket get raised and my team go and they attend that breakdown. So it is a count of event on a particular scope of area. So technically, based on our previous videos, this need to be plotted in a C chart, count of event charts. So I have date wise this information from from 3rd of February. Every day I have data for breakdown. 3rd of February there is a breakdown that is reported, and then 4th of February, 5th of February, like that there is no breakdown. And from there, if I scroll down, 28th of February there is a breakdown. Again, if I scroll down, there is no breakdown. 000. Again on 5th of April there is breakdown. The entire March there is no breakdown. So this is how this data will look like. And as per the general process, an event count of event graph, we go for C chart. So what I do, I click on stats, I go to control charts, and in control charts I select attribute chart, and in attribute chart I go for C chart, and in C chart I select this data which is breakdown. So whenever there is a breakdown, there will be a number. So I select breakdown. If there is no breakdown, it will be 0. If there are 2 breakdowns, 3 breakdowns, that number will also be captured. And I can go to scale and I can select date as my stamp, and I can say OK. And now I can say, I can go to C chart options. I can click on test. I can put a tick mark on all these, but this is event and this is lower the better. So technically, if it is very close to the lower control limit, I'll be more happy. So I'm not going to put a tick mark on all these things. I'm just going to click OK, and you get a C chart. And what do you understand from the C chart? Actually, we understand very little from this C chart. Why we understand very little from the C chart? This chart is drawn for the entire year, and in this entire year, the number of breakdowns are very few. Out of 365 days or out of roughly 300 days, hardly we have about 30 events or 35 events. That's the total number of days in. And if you look at this, yeah, there are some frequent breakdowns here, then there is a long period without breakdown, then there are breakdowns, but actually there is nothing much to really make an inference out of this chart. Okay, so this is the traditional way of looking at it. Now we will look at it from a G chart options. Okay, what is the letter alphabet G refers to? Alphabet G refers to geometric distribution. Alphabet G refers to geometric distribution. Now for a minute, let me take you to the Excel file where I am maintaining this particular data. I have converted this data, which is on a daily basis. If the event occurs, then we will call that particular day as a day where there is a ticket. So what I'm doing is I'm doing a filter on only days where there is a event. I'm doing a filter on only days where there is a event reported, and I am taking only these dates. So these are dates on which the event got occurred. So I copy these dates and I paste it here and I call it date of breakdown. So just a minute. We will call it date of breakdown. Let me change the header. Date of breakdown. Now, date of breakdown, let us assume on 3rd of February there is a breakdown. On 17th of February there is a breakdown. On 20th of February there is a breakdown. And if you scroll down, on 26th of October there were multiple breakdowns reported. Not only in one machine, but at various places in the factory there is breakdown reported. So now this data is copy pasted to my mini tab. Now here I have machine breakdown date. Okay. So now instead of plotting a C chart, now I'm going to plot a G chart. So I click on stats, control charts, rare event chart, and here I select G chart. And what is a G chart? Draw a control chart for the number of opportunities or days between a rare event. So if I keep my mouse pointer here, it says draws a control chart for the number of opportunities or days between a rare event. So what do we mean by that? So let's now start with the first option, because if you use this drop down, there are two options you have. You can select number of opportunities or you can select date of events. So I keep date of events. So mission breakdown date of event is available. So I select this. Again, I can go to scale, timestamp. I can have the machine breakdown date itself as my timestamp. I can go to G chart options. Okay, now in G chart options, the first thing that we can do is what is the historical probability of a machine breaking down. If at all you have this number, you can enter this. From my historical probability, I know the chances of my machine failing is 9.9%. So when I put it in a proportion, it will be 0.099. So the historical if you know this information, you can enter it. If you don't know this information, you can leave this blank. Again, in test, I can put a test tick mark on all this, but as I told, rare event could be a good to have event, could also be a not desired event. So in this case, breakdown is a not desired event. So even if our data points are very close to the lower control limit or upper control limit, because in this case you will find it slightly something different. So for that matter, I'm not going to put a tick mark on any of these boxes. I'm just going to click OK, and I'm going to click OK again. So now we got a chart. Let's look at this chart. This will be an interesting chart. Why this will be an interesting chart? Because if you look at the y-axis of this chart, it says days between the events. It does not say on a given day how many events occurred. No, we are not drawing a C chart. Instead, we are converting our breakdown data into days between the events. That is, so you would have heard terminologies like mean time between failure, MTBF. Right. So mean time between failure is what is the time between two failure events. Similarly, how many failures we have and what is the mean time between failure. So this y-axis talks about days between events. Why we call it as days between events is it's a rare event. So sometimes rare event means a day with 0 ppm is also a rare event. A day with breakdown is also a rare event. So whether it is a good to have event or bad to have event depend upon what we are measuring. Here I am measuring breakdown, which is not a desired event. So what is this first data point talks about? This data point says on 17th. So the first event happened on 3rd of February. The second event happened on 17th of February. The distance between these two is 14 days. So that's why the first data point is blank, and you have data point only for the, or you have a dot only for the second data point in our table. The second data point, so what you see here 14 days is distance between, or the number of days between two mission breakdown tickets that got raised. And if you see here, this is the distance between the second and third ticket, and this is the distance between the third and fourth ticket. So as you see this, if this graph increases, what does it mean? it means the days between events are higher. That means you have more number of days with no mission breakdown ticket that get raised. So which is a good news for a maintenance team. That means your preventive maintenance activity is actually effective. That's why you're not having a mission breakdown. And if you start analyzing this data after some time, what happens? The graph is trying to, or the graph is getting lower and lower. When the graph gets lower and lower, frequently you are having mission breakdown. And if you see on the 10th, what happens? You have only 4 data points. What are these 4 data points? These 4 data points are on 26th of October, there is one mission failure reported. 26th, another mission failure reported. So the distance between the two tickets is 0. The distance between the second and third ticket is also 0 because one more mission failure got reported. The distance between the third and fourth is 0 because one more mission failure reported. And the distance between the fourth and fifth data point is also 0 because one more mission failure reported. Because if you go back and see our Excel file on 26th of October, there are 6 tickets that got raised. So if you see here on 26th of, 5 tickets that got raised on 26th of October. So that is why the distance between the failure, that data is 0. So that means something really wrong or something really bad happened on this day, because of which you are hitting the lower control limit. So when you hit the lower control limit here, can it go below 0? No, it cannot go below. The days between events cannot go below 0. As I was explaining, the G in this chart, G chart, the alphabet G refers to geometrical distribution. So your lower control limit, your central line, and your upper control limit is all calculated based on the formulas of geometrical distribution, which is a deeper statistical subject. Maybe in a different video I will clearly explain the formula, but in the interest of people who wanted to plot charts for rare events, G chart is a better chart than a C chart or a U chart or a P chart or a NP chart, depending upon what you are monitoring. As an attribute data, if it is a rare event, the right metric to measure is not the event, but actually the days between the event. That is what is the correct metric to be plotted when you are plotting a rare event chart. Now let me close this graph and show you something else. So when I press Ctrl E, here I have 2 ways of plotting this chart. One, date of event, another one is number of opportunities. Now we can understand this word number of opportunities in 2 ways. As a maintenance team, what is my opportunity? Every day is an opportunity. And if that day there is no breakdown ticket that get raised, then it's a good day for me. Another next day, no breakdown ticket. Next day, no breakdown ticket. The fourth day, there is a breakdown ticket. Then what happens? The number of opportunities between my 2 rare events is 3 days. That's how I will call it. That means dates between event is a opportunity, number of opportunity. So what I can do is I can plot a chart by getting the date of the event, or I can also plot the chart by getting number of opportunities. Now when we plot this chart using number of opportunities, I'll give you 2 examples. The one I gave is for the maintenance supervisor. Every day is an opportunity, right? Every day plant, if they don't report a failure or a breakdown, that day was a good one for me. If they report a failure, that day is not a good one for me. But I'll take you to a different scenario. Let's say I am a city police commissioner and there is certain number of police stations report to me. As a city police commissioner, one thing which I definitely don't want to happen is a custodial death. When somebody is remanded in a police station and due to various reasons, if there is a custodial death, it is a serious cause of concern for me. The nature of death could be investigated, but as a city police commissioner, I don't like to hear there is a custodial death. That is a rare event, not a desired rare event. Okay. Does every police station every day have a remand opportunity? No. Maybe in a week you can remand 2 people, 3 people. Maybe some police stations you can remand even 10 people. So can I count the number of days um, between 2 different custodial deaths? Is it a right metric? Actually, that's not a right metric. Why that's not a right metric? Because every day I do not have equal opportunity. Then what I need to do? I need to measure it in terms of opportunity. That means every person who get remanded should be given a unique ID, and if at all there is a custodial death that happens, I need to get the ID of the person who was remanded and there is a unfortunate custodial death. Then what I need to do, then I need to draw again a G chart, but this time the G chart is not the number of days between two custodial death, it is number of remanded people between two custodial death. So number of, that's the nature of data, but the nature of data can be equated to days. If there is an opportunity every day, can be equated to opportunities. If there is no opportunity every day, then it need to be equated to opportunities, then we need to only measure it in terms of opportunities. So let's look both these options how to draw it in Minitab. So let me click on stat. So what I have done is I have converted this data here in terms of number of days between failure, because the number of days between these two failures are 14 days. So here I have one particular information to share with you friends. Minitab will ask you which method you want to go for. For example, if you see here, Minitab will give you two methods. Do you want to count opportunities as 0, 1, 2, 3, or do you want to count opportunities as 1, 2, 3, 4? Now, what does it mean? It means if an event occurs on 5th and the event again occurs on 8th, if you select 0, 1, 2, 3 in Minitab, what are you doing? You are actually counting, that is the number of opportunities between event is 2. Why 2? Because 5th it has happened, 6th it did not happen, 7th it did not happen. So the number of opportunities between two failures is 2 days. In the other method, what are you doing is you are counting if the event happened on 5th and 8th, what are you doing is you are counting it happened on 5th, it did not happen on 6th, 7th, and it again happened on 8th. And if you count it 1, 2, 3, 4, then you are calling 3. For example, if I'll make it very simple, if an ID is given to the first person who get remanded as number 1, and then ID is given to the next person as number 2, number 3, the 30th person who got remanded, unfortunately there is a custodial death. So what will happen, the 30th person ID will be called as a person who met with a rare event. Then again people get ID when they get remanded, and the 72nd person, in this case you see 72nd person. So what are we doing here, we are calling in this method 1, 2, 3, 4. Whereas in this case on 26th, what happened on 26th of October, same day multiple failures got reported, so we are calling it as 0, 1, 2, 3. So this is how we need to understand these two options. When I select it, you will know it better. So I click on stats, I go to control charts, I go to rare event charts. In this I select G chart. So I select number of opportunities. So in the number of opportunities, first I am selecting, as I told, when I select number of opportunities, you will have two options. One is opportunity between 0, 1, 2, 3. That means you are counting the event date also. And the second one is you are counting only the opportunities in between two events. So I select this one and I go to machine breakdown data. So days between events, I click OK. I get pretty much the same chart. But this time if you look at the chart, it says number of days between events, right? Okay. Now what I do, I press Ctrl E, and this time I select number of remands to custodial death. So I select OK. But this time I'm going to select this option 1, 2, 3, 4. I say OK, and I get this chart. And how do we do an interpretation of this chart, or what is the inference out of this chart? If you see here, this is a undesired event, and as the graph spikes up, it's a good news, because for 700 days, for example, if you see the distance between this event and this event, almost for 700 days there was no custodial death. That means 2 years we did not have any custodial, sorry, not 2 years, for 700 people remanded, 700 people remanded, there is no custodial death. So that is the information that we are seeing here. But here between two consecutive custodial deaths, the distance is very low. So that's how we need to look at it. Number of events between, or number of opportunities between events, or number of days between events. So friends, I hope this video was useful for you to understand a rare event chart, how a C chart or a P chart will not be helpful in this case. Instead, we need to go for a rare event chart called G chart. So the G chart can be used on cases where we are monitoring a rare event. Hope this video was useful. Thanks for your time. Thanks for watching this video. For more videos on control charts, Minitab tutorials, quality management tools, Lean Six Sigma tools, please subscribe to our channel. Thank you.